so these drop down fill in the blanks can be a little bit confusing sometimes. Remember, percentiles is a percentage, so 30th percentile means that 30% of the values are below that number. Okay, so the relationship between quartiles, like the first quartile is the 25th percentile, right? The third quartile is the 75th percentile. So quartiles are special cases of percentiles, right? Q1, that's the first quartile, is the 25th percentile. Q2, which is also the median, and Q3 is the 75th percentile. That's all we're looking for there. Okay. Let me jump to number 9. Okay, so we want to decide whether or not there are any outliers here, and we'll use the 1.5 IQR rule for that, or really we can just use our calculator and the modified box plot. So first thing I want to do is take all these numbers, and I'm going to put them in a list in my calculator. Okay, so remember how that works. We go to Stat and Edit, and we want to go ahead and clear anything that's in there. I'm going to take those numbers, press Enter. I'm going to take those numbers I have in the problem and enter them in that list. So I can kind of kill two birds with one stone here if I just make my modified box plot. So I have my list in L1, and now I'm going to hit second and y equals. So right now you can see all my plots are turned off. I'm going to press Enter so I can deal with plot number 1. I want to press Enter so that it's turned on. And then the type of plot I want is this first box plot here. It's the modified box plot. So if I do have outliers, it'll flag them for me. Okay. So I don't have a oops, didn't pick it for me. I got to press Enter there. So I press Enter, and now I come down here and you can see it's just L1. That's perfect. And now the shortcut to get a window that'll show me what's happening with that box plot is Zoom 9. Okay, good shortcut to write down. So I can see that I do have a outlier here. And then when I hit Trace, I'm going to use my Trace button up here, I can just move through and get my 5-number summary. There's my minimum. It's 54. They don't ask me for the minimum. So they want Q1, which is 57. Then we have our median, which is that middle bar, 60. And then finally Q3 is 62. Okay. And we do the interquartile range is just 62 minus 57, so that's just 5. Identify any outliers. There it definitely exists an outlier, and he is out here to the right. We could use that 1.5 IQR rule, but we don't need to. We have the modified box plot that flags it for us. So that tells us that 74 is an outlier. Makes life a lot easier to use that modified box plot. Okay. So let's jump ahead to number 18. I want to show you this one because this one I feel like is worthwhile using StatCrunch for. There's so many numbers here, so many decimals. Okay, I'm going to go ahead and use StatCrunch. When I click on this, I can open this problem up in StatCrunch. And sometimes StatCrunch doesn't cooperate with me, so I'll give it another try. I don't know why it does that. Sometimes it doesn't work on the first click. I give it a second try. Okay, so what I want to do here with StatCrunch is just compute some one-variable statistics. Okay, so you're going to click on this menu here under Stat, and it has summary statistics. Okay, so my data is in columns, so I'm going to tell it that I want this column 1. I don't need to do anything fancy or sophisticated here. We can just jump right down here to compute. And it gives us all our one-variable stats, same kind of stuff that the calculator would give us. We'll see what kind of questions they want to ask us here. So they want Q1, Q2, and Q3. So Q1 is right here at 15.2. Q2 is the median, that's 15.8, and Q3 is 17.55. So we start with Q1, 15.2. Q2, what did they say? Type integers or decimal places. Do not round, so I'm going to get that wrong if I don't. Type integers or decimals. Okay, I'm going to go with 15.2. It says do not round. I didn't really round anything there. Median is 15.8. And then Q3. It's just, I mean, you could do this on your calculator. Obviously, it's the same type of problem we've been doing. I just think StatCrunch makes it a little bit easier because there's so many numbers that you would have to type in there. And they liked our rounding. We were okay there. Okay, draw the box and whisker plot. Okay, so StatCrunch can do this for us as well. So if you notice under StatCrunch, we had stat, now we'll go to graph. And box plot is there. StatCrunch does give us more options in the calculator, but I like for us to be able to use that calculator. It's more convenient. Calculator is kind of something you can always have with you, whereas the StatCrunch you may not necessarily always have it available to you. So this is the box plot, but keep in mind we would turn it to the right sideways to match the box plots they give us, so we can see our min here is just below 14, and the max is just above 19. Roughly symmetric, maybe skewed to the right just a little bit. So I'm going to look for a graph that would match that. Okay, so just above 19, just below 14. Let me double check it. This is the one that it seems to remind me of the most. Yeah, it was slightly skewed to the right, if anything. A little bit of a box to the right there. So actually it would be this one here. Looks more similar to what StatCrunch provided for me. Oops. I must not have paid close enough attention to. Yeah, those two graphs look pretty similar to me. Okay, I'm going to jump to number 24. Okay, and here we want to convert the values to z-scores. So you remember with a z-score, it's the raw score minus the mean divided by standard deviation. Okay, so the raw score is 27, the mean is 27.9, and we divide by standard deviation. So I'm going to take 27 minus 27.9, and then I have to divide that by the standard deviation. Let's get rid of that. The standard deviation is 3.5. Okay, so that's going to be negative 0.9 divided by 3.5. I'll just do that on my calculator. Negative 2.57. Let's see what they want us to round that to. 2 decimal places, so negative 0.26, right? Negative 0.26 to 2 decimal places. Okay. Interpret the result. So if this z-score is negative 0.26, it means it's below the mean, right? So it's about 0.27 standard deviations below the mean. That's what a negative z-score would represent. Okay, sorry about that. 0.26 standard deviations below the mean, not 0.27. I don't know why I typed that. 27 is the raw score, 0.26 below, so that was a typo. But yeah, it'd be 0.26 standard deviations below the mean. Determine whether this age is unusual. No, it's not unusual. If the z-score is between negative 2 to 2, it's inside that, then it's not unusual. This is the letter A is saying that if it's outside of that, it's not unusual. This one's not unusual. It's pretty close to the mean, really. It's not even a standard deviation away from it. Okay, so it's on to 25. Let's jump to 27. See what that looks like. So we have the lifespans of a species of fruit fly have a bell-shaped distribution with a mean of 30 days and a standard deviation of 5. Okay, so now we have 3 randomly selected fruit flies, 32, 29, 46. Find the z-score that corresponds to each and determine whether or not these are unusual. Okay, so for each one of these, we're going to take the raw score. So for the first one, we would take 32 minus 30, and divide by 5. So I have 3 z-scores I'm going to calculate here, right? I'm going to do 32 minus 30, and I'll divide that by 5. So when I do that, I'm going to get 2/5, which is 0.4. Okay. For the second one, I'm going to take 29 minus 30 and divide by 5, and that's going to be negative 1/5, which is negative 0.2. And then for the third one, I'm going to take 46 minus 30, divide by 5, and that's 16 over 5, which would be 3 1/5, or 3.2. So those are going to be my 3 z-scores, and then we'll answer whether or not they're unusual. So if I remember correctly, this was 0.4. This one was negative 0.2, right? And what was the last one? 3.2. Okay, so those are my 3 z-scores. Which ones are unusual? Just the one that's 3.2, standard deviations above the mean. That's the only one that we would consider to be unusual. Okay. Determining the percentiles using the empirical rule. Okay. So I need a little bit more than just the empirical rule to find these percentiles. The percentile for a z-score of 0.4 is the area to the left of 0.4. Okay, so I'm going to need the inverse norm feature on my calculator. I'm going to use inverse norm 0.4, and then the mean is 0 and the standard deviation is 1. Same thing here, I need the area to the left of negative 0.2, so that's also inverse norm, negative 0.2, and then 0 and 1. And then finally, this is going to be like, above the 99th percentile. Okay, so I'm going to use that inverse norm feature on my calculator to do each of these. So that's second and the variables key. And I want inverse norm. Not inverse norm rather, but normal CDF, right? So second vars, I'm going to use normal CDF. So for the first one here, I use the inverse norm. We'll use normal CDF. We have the values. So I have my lower limit, which is like negative infinity, and the upper limit is 0.4. So we would use normal CDF. Negative 100 or negative infinity, whatever you want to pick for that 0.4, and then the mean and standard deviation, of course, are 0 and 1 respectively. Same thing here, we would go normal CDF, negative 100 to negative 0.2, 0 and 1, and then negative infinity or negative 100 up to 3.2. So we'll do each of those 3. So for the first one, my upper limit was 0.4. Mean and standard deviation are 0 and 1 respectively. So that percentile is going to be 0.655 or 65th. Now if we just use our shortcut, second enter, all we need to keep doing here is changing the upper limit. So I'm going to use my insert button here, second insert, to insert a negative sign. And this was just negative 0.2. So that's below the 50th percentile. And I'm going to do second enter one last time. My lower limit, negative infinity, is still fine. But now I want this to be 3.2. Still the same mean and standard deviation. Okay, 0.999. So let's see what they want me to round to here. Type in integer or decimal, so we'll say 0.655. 0.42. And then 0.999, I believe. That last one. Yep. Okay, sorry about that. I read through this way too quickly. I thought these were the same numbers that I had up here, but they changed them entirely. So it's a much easier problem. 45-day fruit fly. Right, he's 3 standard deviations above the mean. So what they want there, if you're 3 standard deviations above the mean, right, we know that we have 99.7% in between 3. So if you're living right here, what percentage is out here, right? It would be 100, right? You have 99.7 inside here. So if we take 100% minus 99.7 and then just divide that by 2, that's the area in this tail. So this percentile is everything else. Okay, that's where 99.85 comes from. 84th percentile, right? 35 days. Well, that's just one standard deviation above the mean. So if I'm just one standard deviation above the mean, remember we have 68% in here. So if this is 68%, that means just in here is 34%, right? It's half of 68. And then over here is 50%. So we have 50% and 34%. That's where we get our 84%. And 20 days, okay? 20 days is 2 standard deviations below the mean. So if we go 2 standard deviations below the mean, right here, what area is in that tail? Well, we know from 2 below to 2 above, that's 95%. So that leaves us with 2.5% in each tail. So that percentile for this score would be the 2.5 percentile.